If you have watched our previous video or not yet, then you need to go and watch that one before we are able to watch this one. Because in that previous video, we talk about circle theorems. We give the list of theorems which we will be covering in this particular video. So this video will be strictly for exercises, for doing questions, for solving problems, and going through some of the most difficult questions you can find out there. The 5-mark questions are the ones we will focus on, but the concept itself will be in the video titled Circle Theorems. So I will attach that video somewhere within in the link below or somewhere like that. So you find that video first. But for now, let's look at some real questions on circle theorems. So we are here to look at some questions, different marks, different strategies, and how to answer and how to answer those questions. We will do as many questions as we can in this video. So this is going to be a very long video. So let's buckle up and start. So our first question is question 1. Now, if you look at this question, it just gives you the diagram and tells you that ABCD are points on a circle. PA is a tangent to the circle, so we are already being provided with the information that we will use to solve this equation. Angle PAD is 39 degrees and angle BCD is 103 degrees. Now, this particular question is asking you calculate the size of angle ADB. However, it does not ask for us to give reasons for why we are making the choices or giving the values we are. So such a question is 3 marks. It doesn't ask you for reasons. So if you know the theorems or you don't know the theorems but you can be able to solve the sum, you solve the sum. So this question, I'm not going to write the theorem that I'm using. I'm not going to write it or type it in. Instead, what I'm going to do is just say there is this theorem and this angle is equals to this. So we want angle ADB, that is that angle there. Now, to get that angle, there is an angle we already know. That is that angle ABD. Now, angle ABD is going to be equal to 39 degrees. And we know the reason for that is angles in opposite segments are equal. The exterior angle to the tangent is equal to the angle in the opposite segment. So that theorem, we gave it, of course, all the theorems we are talking about here, you will find in the previous video where we talked about them. So ABD is 39 degrees. So if ABD is 39 degrees, then I have already solved a part of this. There's a second angle I can easily solve. That is angle BAD to finish this triangle. Now angle BAD is going to be equal to 180 minus 103. So again, we are not writing our reason. Now, the reason why angle BAD is 180 minus 103 is because if you look at ABCD, it has 4 vertices touching the circumference of a circle, and therefore it is a cyclic quadrilateral. And opposite angles in a cyclic quadrilateral add up to 180. So if I take my calculator and say 180 minus 103, this gives me 77 degrees. So that is angle BAD. So now we have our second angle, which is 77 degrees. That leaves us with the angle that we have actually been asked in the question, and that is angle ADB. Now ADB is a triangle, and angles in a triangle add up to 180. So this angle will be 180 minus 39 plus 77. So we now have 180 minus, you open the bracket, 39 plus 77, and you get that answer equal to 64. Now, if you can do that in the calculator directly, then you just place it in the calculator. But if you can't, then it's okay. It's very, very much okay for you to add and then subtract, whichever one you find easier for you to do. So we have solved this question without giving reasons. And now let's go to the next question, question number 2. Now, question 2 is broken down into parts. So sometimes, mostly AQA and Cambridge like doing that, having a question that is broken down into several parts. Edexcel sometimes does that also, but their questions would be a bit shorter, just one part or two parts. So if you are given a question like this one, you will see that they ask you to calculate an angle and then give a reason for the value that you've gotten. So our question 2 is 6 marks. And it tells us that A, B, C, D are points on a circle. Automatically, that tells us that A, B, C, D is a cyclic quadrilateral. We will always identify the cyclic quadrilateral. Then we are told now, find the size of angle DAC, angle DAC. So the size of angle DAC, that is that angle. Now, which angle also will have DC at the beginning and at the end? That is angle DBC. So angle DBC, so I just look for the angle we've been given, which is angle DBC. Angle DBC is 55 degrees. So angle DAC is 55 degrees. And so a reason is, the reason we give is angles subtended by the same arc are equal. So if we see an angle and that angle is subtended by the same arc, then those angles are equal. So angle DAC is equal to angle DBC. And then we are told, calculate the size. Now, calculate, and the choice of words is always important. We were finding the size of angle DAC, but now we want to calculate the size of angle DCB. This angle we've determined is 55 degrees, and now we want angle DCB, and that angle is this angle here, this entire angle. Now, if you look at the other side, we have angle BAC, angle BAD, not angle BAC, angle BAD, which is the sum of the two angles. So it is approximately 95 degrees. Now, angle DCB should be equal to 180 minus 95 degrees. So I already know BAD is 95. So this is 180 minus 95 degrees, and that angle is 85 degrees. And what is the reason for our answers? Our reason is opposite angles in a cyclic quadrilateral add up to 180 degrees. So opposite angles in a cyclic quadrilateral, that angle and that angle will add up to that particular angle. Then it asks you a question: is BD a diameter of the circle? Is BD a diameter of the circle? The answer is no. And the answer is no, because we know from circle theorems that the diameter will always subtend an angle of 90 degrees. So we say that it's the angle, the angle it subtends, the angle it subtends is not 90 degrees. So the angle is 95. The angle is 95 degrees. So normally, if the question is broken down like this, we go step by step. We're able to prove the theorems. It's always much, much easier. So let's see what question 3 has for us. Now, question 3 is also similar to what we've done in question 2. We're told P, Q, R, and S are points on the circumference of a circle. If you look at it, that is a cyclic quadrilateral. But the only thing is that there is no line joining QR and PS. Now, sometimes you will find such questions where there's a line missing in one place or another. If that line is important to you are solving the question, then draw it. Now, for right now, we don't know if we will need those lines, or if we will need to complete that particular, we will need to complete that particular cyclic quadrilateral. And because we don't know that, we are just going to continue. That angle PR and QS intersect at point T. Now, T is not the center of the circle, don't assume. In math, nothing is guaranteed to be that unless we are told. So P is not the center of the circle. QS is not the diameter. No one has told us these two things, so they cannot be fact. Angle QPR is 34 degrees, and angle PRS is 41 degrees. Then we are told find the size of angle PQS. Angle PQS is this angle here. Now PQS and PRS are subtended by the same arc. So this angle is 41 degrees. So we'll just write here 41 degrees. And our reason is angles subtended by the same arc are equal. So angles subtended by the same arc are equal. So that is the reason why that angle is 41 degrees. Then find the size of angle PTS. Angle PTS. That is that angle there. Now, to find that angle, we need to find the angle. Actually, we don't need to find another angle. What I wanted to do originally was to add these two, subtract 180, and then subtract 180 again. But we know that in triangles, the sum of the interior opposite angles equals the exterior angle. So I can get angle PTS by simply saying 41 plus 34. So 41, if we take the calculator, 41 plus 34 is 75. Then what I had mentioned earlier comes into play. Explain why T cannot become the center of the circle. So we can say because angle PTS, which we have just found, is not twice angle, any of the angles up there. It's not twice angle PQT or PRS. Yes, so that is a reason. So our reason is to explain why T cannot be the center of the circle is because angle PTS is not twice angle PRS. And we know that at the center of the circle, angle at the center equals angle at the at the circumference. Our next question, question 4, is one of my most favorite questions because it does not limit on which angle I'm going to find first and which theorem I'm going to write first. And like the previous questions that ask you to find this angle, then give a reason, they have limited you on what you can do first and then what can follow. But these questions are different. In these questions, when we look at them, we notice that it's a blank slate. So I can start from anywhere. But what does it really want and what information are we given? Now, PQRS are points on a circle. We already know that's a cyclic quadrilateral and we're meeting a lot of them. Center C. So C is the center of the circle. That information is very clearly given. PCR is a straight line. Now, if PCR is a straight line and it passes through the center of the circle, then PR is the diameter of that circle. Angle PRS is 36 degrees. Calculate the size of angle. We want to calculate the size of angle RQS. Angle RQS. That will be that angle. That is the angle that we want to calculate. And this is going to be so easy because we already know some fact. Now, the first fact we know is that angle PSR is equal to 90 degrees. PSR, this angle up here is 90 degrees. And what is the reason? The reason is, so we write the reason under it, that angles or angle subtended by the diameter, angle subtended by the diameter is 90 degrees. So the angle subtended by the diameter is 90 degrees. So that is angle PSR. Now, we also know, now SP is a chord with an arc, SP passing through that. It subtends angle SRP. It also subtends angle SPQ. We said if the first letter and the last letter, so normally I just move from somewhere, like Q SP and QRP are equal. They start and end at the same place. RPQ, RSQ. All those angles are equal. Now, for our case, we have angle SPQ. So we say angle SQP will also be equal to 36 degrees. Angle and I've even gone far with this question. I've just realized I could have done something totally different. Angle SQP, but let's continue, is 36 degrees. This angle here, 36 degrees. And the reason is angles subtended by the same arc are equal. And you're allowed to write chord there. You can write angle subtended by the same chord, no difference. So that is angle SQP. And so now I can find angle RQS. Now I have two ways of finding it, angle RQS. I can subtract it directly from 36 degrees, or I can add 36 to 90 and then subtract it from 180. So I'm going to go with the simplest one, 90 minus 36. And we are going to say that is 90 minus 36, that angle is 54 degrees. And the reason, we're going to give the first reason we gave, that angles subtended by the diameter is 90 degrees. And even if I would have gone with angles in a quadrilateral, opposite angles in a quadrilateral add up to 180, it still work. The thing about circle theorems is the theorem will always work no matter the path you choose, no matter the path you choose to follow. So in this case, we've decided let's follow this path. I always say in math, if you have two paths to follow, then follow the easiest, shortest path. That's what you do. You follow the easiest, shortest path. Don't follow the longer one. So let's get on to the next question. Now, in question five, and I always love the fact that circle theorems, each question is always unique. It has a unique twist to what it wants you to do. We are told A, B, C, D are points on a circle, cyclic quadrilateral. ABE and DCE are a straight line. So ABE and DCE are straight lines. Remember, they're not tangents. AT is a tangent, so there's a tangent down there. Angle EAT, angle EAT. Now, my mind went to BAT and I was like, where is E? And E is all the way up there. E is 47 degrees. And the bad angle BAD is 56 degrees. Then you are told find the size of angle AED, angle AED. So now I want you to notice something. DCE is parallel to AT. So this line is parallel to this one. So this angle and this one are alternating angles. So this angle is 47 degrees by the virtue that this is 47 degrees. And this is something that students sometimes forget, that you can pick any angle property to apply here. Angles in a triangle add up to 180. Angles in a straight line add up to 180. Angles at a point add up to 360. Alternate angles are equal. So 47 degrees. And the reason for my answer is that alternating angles are equal. And this is the first time we have stepped away from the real theorems and going to look at other angle properties to solve. Now find the size of angle BCD. BCD. That is that angle, the angle BCD. Now, angle BCD, we can calculate it because ABCD is a cyclic quadrilateral. BCD is opposite BAD. So, angle BCD is going to be equal to 180 minus 56. So, 180 minus 56 is 124. That is the size of that angle. So angle BCD is 124 degrees. Now there was no reason asked for that, so we'll just leave it. Now find the size of angle ADB. Angle ADB is this angle here. And so angle ADB will also be 47 degrees. And for this, we give a reason. We say exterior angle to a tangent equals angle in opposite segment. Or sometimes sometimes you'll find in some books they write it equals the interior opposite angle. It's a term you can use. You can say this angle here is equal to the interior opposite angle. And you see, normally when they write it like this, it's easier to do than question 4, where in question 4 you just had to figure out what you had to do. And so that is the last one. So let's look at questions. We've done question 5. Let's do question. Now let's roll into question 6. And in question 6, we have another very nice shape. A, B, C, D are points on a circle, center O. So A, B, C, D are points on a circle. AE is a tangent. Angle ADC is 68 degrees. So ADC, that angle there is 68 degrees. You see how they give you minimalistic information. The rest of the information is there for you to find while solving the problem. Now, one, find the size of angle ABC. Angle ABC. That is this angle here. And this angle here, so we will say angle ABC is equal to 180 minus 68, because this is a cyclic quadrilateral. I didn't mention it because I've been mentioning it on every single question since we started. So I said, let me not mention it this time. It will just pop up. Most of the questions you notice will always rely on the cyclic quadrilateral. So 180 minus 68 is 112. And a reason for your answer is opposite angles in a cyclic quadrilateral add up to 180 degrees. So that is done. So opposite angles in a cyclic quadrilateral add up to 180 degrees. Then find the size of angle AOC. Angle AOC is at the center. So that is 68 times 2. So 68 times 2 is 136. And so because it's 136, we say the reason is angle at the center is twice angle at the circumference. Angle at the circumference. So angle at the center is twice angle at the circumference. So that is the reason why we multiply that by 2. Then we are told find the size of angle CAE. This angle out here. Now this angle, you can see it subtended the other angle. This chord that is out here creates a mirror. It's an angle on the other side that is 68 degrees. And that is another very good sum. So let's move. Okay, now let's look at question 7. And in question 7 is just 3 marks, just one question solved on its own, and then the second question we give a reason for our working. So we are told D, E, F, G, H are points on a circle. Those are 5 points. So it doesn't make a cyclic quadrilateral. However, 4 of those points do make a cyclic quadrilateral. So H, D, E, and G is a cyclic quadrilateral. H, D, E, and F is also another cyclic quadrilateral. So although the total shape is not a cyclic quadrilateral, we have 2 cyclic quadrilaterals in this particular question. Now the first part, it says find the size of the angle marked EFH. That is this angle up here. The angle EFH is this angle up here. And that angle will be equal to angle EGH. So EFH will be equal to EGH, and therefore this angle is 67 degrees. Then we are told, part B, Roman 1, find the size of angle EDH. Angle EDH. Now, EDH is this angle here. And this angle You see, that is a cyclic quadrilateral. That is a cyclic quadrilateral. It is opposite both angles. So it's opposite this angle and it is opposite this angle. And so this will be 180 minus 67. So let's have that 180 minus 67, and this would be 113. So 180 minus 67, that is 113. And the reason is opposite angles. The reason is opposite angles in a cyclic quadrilateral add up to 180 degrees. So opposite angles in a cyclic quadrilateral add up to 180 degrees. So that is a very simple case and a very simple question. Let's move on to the next one. Okay, now let's look at number 8. And in number 8, we have another cyclic quadrilateral. So we said we're going to have most of the questions will always revolve around cyclic quadrilateral. And the first question, A, B, C, D are 4 points on a circle, center O. AD is a diameter of the circle. So we've been told AD is a diameter. So we have that information with us. Then BAD is 58 degrees. We know ABD is going to be 90 degrees. Then we are told calculate the size of angle ADB. The size of angle ADB. So angle ADB is this angle here. Now this is a right angled triangle. So angle ADB should be equal to 90 minus 58 degrees. So we should have 90 minus 58 degrees, and so that angle is 32 degrees. That's all we need to do. That is all we need to do. That's all we need to do for that. Now, this question also does not require for us to give a reason for our calculation. So we don't give any. Normally, if the question does not ask you for a reason, you don't give. See, the second part now asks for a reason. Calculate the size of angle BCD, this angle here. Now, you notice that this angle is opposite BAD. They are opposite each other. And we remember the rule for that. So our calculation will be that angle BCD is equal to 180 minus 58 degrees. So 180 minus 58 degrees is 122. And what do we say to that? We say opposite angles. We say opposite angles in a cyclic quadrilateral. In a cyclic quadrilateral add up to 180 degrees, and that is our rule for that particular question. So the second one wants a reason, so we give a reason. Well, let's move on to the question number 9. So here is question 9. In question 9, we are told Q, R, S, and T are points on the circumference of a circle. PU is a tangent. So now we have a tangent. PQR is a straight line. PQR is a straight line. PQT is 108 degrees. So PQT is 108 degrees. Angle STR is 44 degrees. Work out the size of angle STU. So we want the size of angle STU, giving a reason for each step of your working. And so we know that angle STU is that angle there. That is angle STU. Now to find it, we need to find several angles, and we are going to give each step. We're going to give a reason for each step. So let's start. To find out the size of angle STU, we need angle TQR. So angle TQR, this is the angle we are going for. Angle TQR is going to be 180 minus 108 degrees. And the reason for that is very simple. So we have 180 minus 108 degrees, and that is 72. That is 72 degrees. And what is the reason for that? We know that angles in a straight line, angles in a straight line add up to 180 degrees. So angles in a straight line add up to 180 degrees. And so that gives me that angle as 72 degrees. Or I can get angle TSR directly. So now angle TSR, the angle on the opposite end is 180 minus 72, which gives us 108. And I know I would have just said the exterior angle to a cyclic quadrilateral equals to interior opposite angle. So that is a way easier way to approach it. But then we will say now here we've already calculated, and our reason is opposite angles in a cyclic quadrilateral quadrilateral add up to 180 degrees. And so that is the reason for that angle up there being 108. Then we get the angle we want, angle S. First we get angle SRT. So angle SRT is equal to 180 minus 44 plus 108. 180 minus the sum of the other two angles. And this is equal to 180 minus 44 plus 108. That is 28 degrees. And the reason for this, angles in a triangle, angles in a triangle, add up to 180 degrees. Then we can now give angle STU. So angle STU is equal to 28 degrees. And reason is exterior angle to a tangent, equals interior opposite angle. So exterior angle to a tangent equals interior opposite angle. So that gives us a very, very simple and well-structured answer. So we have one more question left. I just wanted us to do 10. Wanted to do more, but I feel the video will be too long. So let's do one more and then we close it. Now for this final question, I wanted question of 6 marks, a lot of things going on in the question and a lot of reasons to just try and finish this with very top-notch question. So in question 10, we are told A, B, C, D are points on a circle. I think that is now becoming a song and very boring towards the end, like, oh, you've said that 50 times. Find the size of angle ACD. That is ACD is that angle there. So that angle will be equal to this 54 degrees. And we say that exterior angle to a tangent, equals Exterior angle to a tangent equals interior opposite angle. Opposite angle. Then we are told explain why BD is a diameter. Now to know if BD is a diameter, we need to do 54 plus 36, which is 90 degrees. And then we will say therefore BCD is equal to 90 degrees, and so BD is a diameter. So because that they subtend an angle that is 90 degrees, and we know the diameter will always subtend an angle that is 90 degrees. Then we have, of course, work out the size of angle ABC. ABC. This angle is opposite the other one, cyclic quadrilateral. I hope by now you've noticed that there are a few concepts that keep being said over and over again. And so your aim is to understand them. 102. Once you understand those particular concepts, the rest become easy. And the reason for this is opposite angles in a cyclic quadrilateral add up to 180 degrees. And so that particular sector would be done. And so we have managed to do 10 sums, which is very, very good. So with that, we have finished 10 questions on circle theorems. There's still more questions that could be done, but we were not able, or we cannot be able to fill all of them. Originally, I'd intended to do 16 questions, but I had to cut them to 10 because if you've noticed, my chart changed, which means I had started the video at another time, then wanted to finish it over the weekend. I was not able to do that, and so the video has come to another week because there are a lot of things happening in between. And of course, I have a second channel that is giving a masterclass in business administration. So that is also something that I work on. But I will try to make sure that I post at least one video a week. And if there's any topic or any area in mathematics you would like us to cover, then feel free to hit us up, write in the comment, like and subscribe. See you in the next one.